Given the points 0, 0, 1, 6, and 4, 2, which of the below integrals could represent the area of the formed triangle? Okay, so we got 3 points, gives us a triangle. Seems reasonable, I'm good with that. And so the idea here is we connect the points. I'm going to assume first quadrant, except for 0, 0. That's kind of quadrantless without quadrant, sans quadrant, right? 1, 1, 2, 3, 4, 5, 6. 2, 3, 4, 1, 2. Okay, so we got triangle like so. Bah, that's not gonna work. Purple. So we got a triangle that looks kind of like this. And the idea here is we want to set up an integral to find out what's going on here. So what we're going to do is we're going to break this up into 2 parts. The first part, where we're going to find the area of, do some purple. No, we already have purple. Orange. We'll first find this area, and then for the second integral, we'll find this area. And this point right here is 1, 6. So we'll do an integral from 0 to 1, and then we'll do another integral from 1 to 4. Because this point over here is at 4, 2. And so for this first integral, we're going to want to know what this line here is. So to find the line between 0 and 1, 6, so we have 0, 0 and 1, 6. Find the line between them, we're going to want to know the slope. So m equals rise over run, which is 6 minus 0 all over 1 minus 0, which equals 6. So then we can take one of these points, then we'll do y minus y1 equals m x minus x1. And this will give us the equation for the line. I think in y-intercept form, is that the term? Y-intercept form. Y minus 0, which will be y, equals m, which we found was 6, times x minus 0, which equals 6x. So this first equation here will be 6x. Then we'll subtract off the equation for this line right here. We're going to do the same idea to find the equation for that line. So m, the slope of this line right here, the bottom one, will be rise over run. So we have 0, 0, and 4, 2. So we'll do 2 minus 0 over 4 minus 0, which equals 1/2. Y minus 0, we'll use this point to find the equation of the line, because zeros are easier to work with, equals 1/2 x times x1. So x is 0, so y equals 1/2 x. So minus 1/2 x. And then for this equation here, we'll have, we will add some other value. Oh, and then there'll be a dx here. And then again, we'll subtract off the negative 1/2 x dx. Now, since we don't actually have to solve the integral, we just have to pick it out, I'm going to take a look at our options and see if this is a possibility. So it looks like we're on the right track so far. We've got 0 to 1, 1 to 4. So we got this one and this one. So these are their 2 possibilities. So we have 6 minus 1/2 x dx. Yep. Adding some value. And then here's our negative 1/2 x dx. So the question is, so this is negative. So this is probably the one we want right here. But I should probably find this portion right here just to make sure that this is, we're going the right way. Yep. So we'll find the equation of this line right here, find the area under this line, and hopefully it equals that. If it doesn't, then we're in trouble. I just tried to avoid finding the area of that line because it doesn't involve 0, 0, so it's a little bit more cumbersome. That's okay. We can still do this, not that big a deal. Okay. So equation for that line, we have 0.16 and 4, 2. Our slope will be y2 minus y1, x2 minus x1. And so we have, what is it, 2 minus 6 and 4 minus 1, which equals negative 4/3. Okay, that looks like we're heading in the right direction. And then I'll use 1/6, so y minus 1 equals negative 4/3 times x minus, wait a second, y minus y1, y minus 6, good catch, negative 4/3 x minus x1, so minus 1. So we have y equals negative 4/3 x plus 4/3 plus 6. I just moved the negative 6 over to this side. And that 6 is 18/3. So this gives us negative 4/3 x plus 22/3. Let's see how that stacks up. Ah, it's even, yes, good for us. Good for us. So, okay. So now we actually know that this answer right here is the correct one. Oh, that was terrible. I erased the whole thing. I just wanted to erase the top line. Okay. Backtrack. Look, see what we did here. So we're given 3 points. We're like, all right, here's some 3 points. Connect these points, and you have a triangle. Find out the area of this triangle. And so we're going to find this area through integration. There might have been some other easy geometric way of doing this. I don't know what it is. Maybe. No, don't know. So, So the way we did this was we found the area under the curve using integration. We found an equation for each of these lines. So we started with one line, and we said, all right, if we find the area under this line, subtract the area under this line up to this point of 1, from 0 to 1, then that would give us this area in this left part of the triangle. Then to find the area in the right part of the triangle, i.e. from 1 to 4, we then, in our eraser. We then took the integral of this top line, which we had to find here. I was hesitant to find it just because it was more cumbersome, but we did it. It wasn't too bad. And then we subtracted off the area under this secondary line, which we already knew. It was like negative 1/2 x integrated. And so we found that, and then we put our entire integral together, and we matched it up to the integral we were given. And it was pretty straightforward. So there's no funny mixer matching or even simplification that would have made life more difficult. So that's how you do this problem. That's how you approach it. That's how you look at life. Well, calculus-based life. And that's how you get the solution. So hope this helped you guys. I will see you on the next problem.